All right, in this video, we're going to do an old problem, but we're going to use the power rule, which is a new tool in our tool belt, to do it more efficiently. I also want to indicate the difference between finding the slope of the tangent line and the equation of the tangent line, which my students historically have gotten confused about. So we've got a function, it's a polynomial. We're asked to find the slope of the tangent line of f at the point where x equals -2. Now, if you had to use the limit definition, it would be annoying because you'd have to simplify expressions like x plus h to the fourth, x squared, right? A lot of canceling. There's a lot of room for algebra mistakes. But now we have the derivative rule for the power rule, rather, for the derivatives. So in order to do this, we need to note that f prime of x, according to the power rule, is 4x cubed minus 2x. The derivative of -2 is 0 because it's a constant. So now we have our derivative, and so now we evaluate it at x equals -2. So f prime of -2 is 4 times -2 cubed minus 2 times -2. -2 cubed is -8. -8 times 4 is -32, and this becomes a plus 4, so I get -28. Okay, so the slope of the tangent line, again, is the derivative of the function at that x value. Now it says find the equation of the tangent line. For an equation of a tangent line, we need a point and we need a slope. So the point we have needs, the point we're interested in has an x value of -2. We need the y value, right? We need f of -2. We haven't got that yet, so let's do it. F of -2 is equal to -2 to the fourth minus -2 squared minus 2. -2 to the fourth is 16, minus 4 minus 2, so I believe that's 10. And now we use point slope form. So in another video, we took a look at this form here. That's point slope form. One thing you might want to get in the habit of noticing is, first of all, in calculus, you're often looking at it in this form. But not only that, the expressions are more as they are appropriate for calculus. So really, you're going to want to get used to this expression, y equals, so the y value is f of 1 plus f prime of 1 x minus 1. This is a better thing to kind of download into your brain as you move forward in your calculus experiences. So f of 1 we learned, sorry, where did I get the 1 from? I don't mean 1, I mean -2. So x minus -2 is x plus 2. F of -2 we learned was 10. F prime of -2 we learned above is -28. X plus 2. So we have the equation of the tangent line. In red above is the slope of the tangent line. It's never a bad idea to go and check to just ensure that your tangent line is doing what you want it to do, which is behave like the function. So our function was x to the fourth minus x squared minus 2. So I am going to take a look at what that gives me. So the function was x to the fourth minus x squared minus 2. And we came up with the tangent line that looks like this, y equals 10 plus a -28, so minus 28, x plus 2. Okay, that is the tangent line. The tangent line is at x equal to the curve at x equals -2. And so, I mean, at this scale, you can't even tell them apart in some sense, right? They're almost identical. If we kind of adjust the window here, so if we make our window, negative, let's make it like -3 to -1. We don't really need to even see more than that. And let's just make sure our y value goes up to the y value like 10, but this is good enough. And I'm just kind of zooming in on the window. Again, we see that the closer you are to the point of tangency, the more the line and the curve behave as though they're the same. So that was just a way of using the power rule to do a problem that hopefully you had done before without knowing it.